everyone. Now, let's get into the intricacy of Java security with our next presentation. Our next talk is titled Java Authentication and Authorization Service, JAAS, is all you need, reviving JDBC again and again. The speakers are from Alibaba Cloud, Zhou Ji'an, and Ji'an Li, are renowned security engineers specializing in Java and cloud-native security. They have reported many critical vulnerabilities to big organizations such as Amazon, Apache, Cloudera, and Microsoft. Let's welcome the speakers to the stage.
Thanks everyone, and hope you have a nice coffee break. And also thanks for welcome. And I'm very honored and excited to be here. And so today my topic is JAAS is all you need, and reviving JDBC again and again. So before the session, I have a small question. So how many people are doing web security research? And please raise your hand. And oh, cool. And so let me briefly introduce myself. I'm the security engineer from Alibaba Cloud, and I'm also a bug hunter specializing in cloud security and web security. I'm also a CTF player from AA team, and I have previously spoken at BlackHat and Eurocon, and this is my Twitter handle. And also today I'm doing AI security, and if you're interested, then you can contact me via Twitter. And so here, this is the agenda. So first, I will briefly introduce the basic knowledge of JDBC, and then I will share the past JDBC vulnerabilities, and I will talk about their limitation, and I will talk about the chance encounter with JAAS, and then I will talk about this novel JDBC attack and its impact and defense implementation and summary. So first, what is JDBC? And JDBC stands for Java Database Connectivity, and we can use Java application to use JDBC to connect to the database. And you can see that it supports a wide range of databases like Oracle, MySQL, SQL Server, and all of the database. And this is a demo code, and you can see that JDBC is very convenient to use, and we just need to set the JDBC URL, and you can see that we configure the database host address, port number, username, and password, and we can use get connection function to connect it and just write a query and execute and get the result. And JDBC is very convenient and user-friendly, and we don't need to know the underlying protocol. And for example, here, we don't need to know the MySQL communication protocol, and we can just focus on writing code, and which is very helpful. And there is only one thing need to emphasize at this time, and you can see that because each vendor will implement its own parsing logic for the JDBC URL, and they may write slightly, but they have something in common, and you can see that they generally include something like database information and some optional properties. And next, I will talk about the past JDBC vulnerabilities. And so here, as far as I know, and this may be the first public sharing of the JDBC attack, and in the BlackHat Europe 2019, and this is a very interesting talk. And at that time, they just shared the classic JDBC vulnerabilities and the Deserialization attack in the MySQL JDBC driver. And after that, there is another talk about JDBC attack in Hacked in the Box Conference 2021, and also another talk about JDBC in the BlackHat Asia 2023. And when you search on the Google, and you can see that there are a lot of JDBC vulnerabilities. And so JDBC vulnerabilities don't seem particularly novel, and so why I'm still talking about it. And so calm down and let me explain. And so let's just go back to the first bug in the BlackHat Europe 2019 and take it as an example. And you can see here, the core exploit method is to leverage the parameter in the JDBC URL. And this is a poke, and you can see that it just sets some optional parameter like character encoding to prevent some encode and decode bug, and set use SSL to false. And the most important part is the query interceptor and the auto deserialize. And this is the exploit flow, and you can see that. So first, we set the JDBC URL to the JDBC driver, and the driver will try to connect to our evil server, and our server returns some malicious payload to the client, and the client will deserialize and achieve RCE. And so now let's analyze the code. And so what is the query interceptor? And it is something that allows you to inject customer logic before and after SQL query is queued. So it is commonly used like SQL monitoring for log queries, measure performance, and it can also use to query modification. We can rewrite or block some unsafe query. And by default, MySQL JDBC driver provides the server states differ interceptor. And so it will automatically execute the pre-process and post-process method. And you can see that they will both call public map with session state value function. And so here, this is a function, and you can see that it just execute a query, show session states, and call the result set to map function. And here, this is the result set to map function, and it just call the get object function. And here, this is the function which has the deserialization payload problem, and you can see that if we set the auto deserialize to true, and it will go to the deserialized logic, and we can achieve RCE. So that is why we need to set these two parameters. And this is undoubtedly a very interesting bug, and also has a significant impact in Java security because it just introduced an entirely novel attack surface. But however, both this vulnerability and subsequent JDBC vulnerabilities have their limitation. So what is the limitation? And if you remember that the sink, the buggy classes are of course in the MySQL JDBC driver library. So what does this mean? And if we find a bug in MySQL JDBC driver, and since the SQL server or PG don't have this kind of code implementation, so we can only influence MySQL JDBC driver. So is there a universal vulnerability which we can influence a lot of JDBC driver? And so I had always wanted to find this kind of vulnerability until I accidentally met with JAAS. So the story began with one day, and when I came to work, and my boss just said to me that I heard the zero-day vulnerability about Kafka client in the metric cup competition, and so try to find it out. And so just fine. And the question is how to find a zero-day vulnerability. And if you want to find some zero-day vulnerabilities, and it is a good idea to learn from the past CVEs. And historical vulnerabilities can help us quickly familiarize ourselves with a new component. And here, the CVE 2023-25194 may be the most famous bug in the Kafka and the Kafka client, and let's dive deep into it. And here, this is a poke, and you can see that it is maybe a little bit complex. It sets a lot of properties like bootstrap server, which defines the Kafka server address, and some other property. But the most important part is the sasl.jas.config, and you can see it may be a little bit complex. It says something like JNDI login module or user provided URL. And now let's just want to reproduce the vulnerability and don't dive deep into it at this moment. And here we also need to run an evil JNDI server, and this is an open source tool, and you can try it yourself after the conference. And when we run the code, you can see that we just caused an exception. So did we fail? And when we check our evil JNDI server, and you can see that it just reserved an LDAP request, and our server just returns some evil payload to let the client execute the open calculator command, and you can see that it's successfully executed. So it seems very interesting. So what happened? And here, this is the exploit flow, and you can see that first we just set up an evil JNDI server, and then we set the evil connection string. And the Kafka client will send the lookup request, and our server will return some evil payload, and we will achieve RCE. And let's dive deep into the vulnerability to figure out what behind this. And here we will focus on analyzing the most important part, since the entire process is highly complex. So first, you can see here, here in the load client context function, we just get configuration from the sl.js.config, and then we use this configuration to generate some instance like JS-config or JS-contents. And then in the login function of the abstract login class, and you can see that it just create an instance of the login context and then call the login function. And you can see the configuration here is our JNDI login module. And here, this is the login function of JNDI login module, and you can see that it just calls the temp authentication function. And in this function, it just creates an instance of initialized context and call the lookup function. And the parameter here is the evil LDAP address we can control. So if you are familiar with Java, and you may know that in Java, when the attacker can control the parameter in the lookup function, and it will cause remote command execution. And because some people may not be familiar with Java, and I will briefly introduce it. And the lookup function of initial context is a very common thing, like runtime execute object input stream with object. So lookup with an untrusted redress will lead to RCE. And the flow is in the right picture, and you can see they are similar. And this is a talk which introduced the GNDI attack surface and in the BlackHat USA 2016. And if you're interested in the GNDI, and you can refer to this great talk. And so when studying vulnerabilities, an important step is to know the sink. So where is the sink in the Kafka client vulnerability? And so wait a moment, and the sink just lies in the JDK. And so at that time, I just have two ideas in my mind. So first, why the sink in the JDK? And if it is in the JDK, and maybe other components will face the same risk. And what behind the JAAS? And we may need a better understanding of it. And here, the magic behind this is JAAS, Java Authentication and Authorization Server. And if you remember yesterday, Ricky also talked about some security mechanism in Windows, and so interesting and awesome. And today also, James also talked about some interesting vulnerabilities about NTLM and Kerberos. But I don't have time to update my slide, so sorry, James. And you can imagine that there is another very strong dog. And so I also talk about the security mechanism in Java, and so what a coincidence. And so what is JAAS? And JAAS is a popular authentication and authorization framework, and it allows authentication via username, password, LDAP, or Kerberos. And here, this is a demo provided by Oracle official guide, and if you are interested, and you can try yourself after the conference. And here, this is the code, and for now, we just want to use this demo. And this is the configuration of the JAAS config, and you can, but here you only need to know that the configuration set the username and the password. And here, this is a demo, and you can see that when we first run this code, and we need to input the username and the password. And if we input correct and just log in successfully, and we run the code, and if we input the wrong password, like test123, and it just causes an exception, and username password incorrect. So just so magic. And now let's dive deeply into the code. And so first, you can see that it says the system property java.security.all.login.config to our JAAS config field. And this is the JAAS configuration structure, and you can see that first is name used by the application to refer to this entry. So our name is symbol, and then is the login module, and here we just use our self-implement symbol login module, and we set the flag to required and some options like username and password. And here, after that, we will create an instance of login context, and you can see that the first parameter is the name of the JAAS config, so it's symbol, and the next parameter is the instance of callback handler. And here, this is my callback handler, and it only has a function called handle. So when instantiate the class, it will not do anything special, and we will introduce the handle function when we actually call it. So let's make a quick summary of the previous code. So here first we set the JAAS configuration to the system property, and then we set the entry name and callback handler to get an instance of login context. And the login context will get the JAAS config URL from the Java system property, and it will find the JAAS config specified by entry name symbol. And so after we get an instance of login context, and we can call the login method to login. And here, this is the login method, and we just create an instance of subject, and then we will call the invoke privilege function. And so first, we will invoke the login method, and then we will invoke the commit method. And you can see that they are just stands for string login and commit. And here, let's analyze the invoke privilege function, and which in fact is the function I showed here. So the original code is very long, so I divided into several parts to introduce. So first, when we first call it, especially we invoke the login method, and the model in the model stack is null. So we will go to the else branch, and then we will instantiate the login module, and you can see that it will get the entry, get the login module, and get the constructor, and call the new instance function to create an instance. And it will put the instance in the model stack, so next time we will not go to the else branch. And then it will just call the initialize function in the login module. And here, since the sample login module provided by the get don't have the constructor, so we only need to analyze the initialize function. And so here, you can see that it just has some basic fields and also set the expect username and password from our configuration. And here, this is the abstract flow, so you can see that our login context will first instantiate the subject, and then we'll construct the sample login module and also initialize with subject and callback handler and some options. And after we finish the instantiate and the initialize method, it is time to invoke our login method. So first, it will get the method and compare to get the correct one, and then invoke. And so here, let's analyze the login method of sample login module. And you can see first, it will create an instance of name callback and password callback, and it will pass to our callback handler to handle. And this is our handle function, and you can see that if the callback is instance of name callback or password callback, and it will just let the user input the username and password from the system standard input. And this is the input window, and just the same as what we show in the video. And so now we just add 2 more steps: obtain username, password, and return the name, password, and to the sample login module. And since we get the username, password from the user input, and it is time to perform authentication. So we compare the username, password with the preset username, password, and if it don't match, and it will cause an exception, and otherwise it will succeed. So now we just add an authentication step. And if we log in successfully, and then we will go to execute the commit method. So here, it just create an instance of sample principal and then add with our username and then add it to the subject. So here, we just finish logging, and after we log in, and we can get the user subject. And you can see that we just log in successfully as an admin. So now you have understand how to use JAAS and how it works. And these are the core classes and interfaces in the JAAS. So first is the subject, and it just represents a grouping of related information for a single entity such as username, person. And the login context just provides the basic method to use to authenticate the subject. It also provides a way to develop an application independent of the underlying authentication technique. And you can see that the login module just implements different authentication techniques like LDAP, Kerberos, and the callback handler. Just a login module will use the callback handler to both to get the input from users or to supply information to user. And the login module will pass an array of callback to the handle method of callback handler. So do you think this may be a little bit familiar? And so by default, JDK provides us with the JNDI login module. And if you remember in the Kafka client vulnerability, and the vulnerability just leverage the JNDI login module. So wait a moment, what will happen if we modify the JS configuration in the demo to our payload in the Kafka client? And the answer is we can just achieve RCE again. So at that time, I found that controllable JS configuration can lead to RCE. And so you can see that. So whether or not in the Kafka client vulnerability or in our JS demo, we can control the JS configuration by connection string or eval JS config, and then it will set the JS configuration in the login context, and finally it will use JNDI login module to log in, and it will trigger JNDI bug, and we can achieve RCE. So here we can know that the issue in the Kafka client lies in the improper integration of JAS. So if an attacker can control the JS configuration, and that will be a problem. And when I simply search JAS on the Google, and you can find that JAS is widely used. Since at that time I happened to be learning JDBC, so I naturally thought of it. Does JDBC support JAS? And the answer is yes, it indeed supports. And so next, come to this novel JDBC attack. So in the previous section, I just said that JDBC supports JAS. So you may be curious about how do I know it. So don't laugh me, and I just first ask GPT, and you can see that it is very clever, and it just tells me the right answer. And also I search on the Google and find that the PG official document has mentioned this interesting feature. And here this is a document, and you can see that it just records some parameter about JAS. So let's go to analyze the code of the JDBC driver. And based on our previous knowledge, and we may know that the possible thing is the login function of the login context. And you can see that it indeed calls the function. And what's more, and you can see that by default, the JAAS application name is PGJDBC. So our JAAS configuration name is PGJDBC. And this is very interesting. So we need to know who calls the authenticate function. And here in the do authentication function, you can see that it indeed calls the authenticate function. But so far, it seems still unclear about how to trigger the vulnerability. And at that time, I don't have idea how to trigger the bug, and I just dive deeply into it, and I want to know why PG implements this feature. And you can see that it just needs to satisfy the authentication between the client and the database server. So now it seems clear the only thing we need to do is to let the client use JAAS API authentication. But the question is, how can we specify the authentication method used by the client? And if we take another look at the JDBC driver, and you can see that the client just responds differently based on the payload returned by the server. So we can just need to return some carefully crafted payload to the client, and the client will follow the instruction and to use JAAS API authentication. So first, we need to run an evil PG server. And this is the server-side implementation and just a very simple socket program. And you may be curious about how can I write this code. And so first, I just start a normal PG server and use Wireshark to monitor the process. And then I just debug the driver to let it to enter the logic we want. So here, there may be not any special technique, just debug. And even if we can step into the logic we want, another question is how can we specify the JAAS configuration? So here, let's go back to the implementation of the JAAS and let's analyze the constructor of the login context. So you can see that it just calls the init function. And in the init function, it also calls the get configuration function. And here, this is a very long and complex function, but we only need to know that it creates an instance of the config field. And here in the config field function, and we need to analyze the instantiate process. You can see that first, it has a field named SPI. So when instantiate the config field, it will also instantiate the SPI. And in the instantiate process of the SPI, and it will call the init function. And so here it will get a configuration, get the system property of the Java security auth login config, and then it will use a new URL function to fetch the field. And also in the previous section, and we just set it to the field on our local file system. But in fact, it can also accept the HTTP URL format. So we can just put the evil field in our remote HTTP server. And also, it has a complex and deep logic. So first, it will try to get from the system property, and if there is null, and it will try to get from the security property, the login config URL1. And if them both null, and it will try to get the property of the user home, and it will know our home path, and we will try to get the field under the path and we'll try to load it. So now you can understand why our JS demo need to set the system property. And here, this is the poke, and you can see that we need to set a system property to our remote JS configuration, and then we set the JDBC URL. And below is the similar JS configuration, we only need to change the name. And here you can see that our UOPG server will receive the request from the client, and we just return some malicious payload to let it use JS API to log in. And then the client will fetch the JS configuration on our remote HTTP server. And then it will try to connect to our JNDI server and send an LDAP request. And we just return some payload to let it to the open calculator command, and we can achieve RCE. And here, this is a demo. And so first, this is a configuration file, and this is the Java code. And we start an evil PG server, we start an evil HTTP server, and we start the evil JNDI server. And when we run the code, and you can see that just RCE here. And here, this is the exploit flow, and you can see that first we need to set up the evil JNDI server, evil PG server, and evil HTTP server. And then we set JS configuration by the system property, and we set JDBC URL to the JDBC driver. And the driver will try to connect to the evil PG server, and we will let it use JAAS API to log in. And then the JAAS we'll try to get a JS configuration field in the remote HTTP server, and it will do authenticate, and we'll send a lookup request, and we will return some payload and achieve RCE. And here we first name this kind of vulnerabilities like controllable system property. And also another two JDBC drivers have the similar issue. So here is the poke of the Microsoft SQL Server JDBC driver. And here we need some modification of the JDBC URL. We need to set something like encrypt to false or authentication schema to Java kernels. And then we need to modify the name of the JAAS config. And this is our evil Microsoft SQL Server. And here, just like a previous bug, and we just return some payload to let the client use the specified authentication method. And Microsoft has confirmed the vulnerability and assigned us with CVE 2025-30706. And the poke is similar to JDBC driver, and we only need to modify the entry name of the JAAS config. And here we only focus on the run function, and you can see that we also fake the server return code to let the client use Kerber's login, and it will trigger the bug. And these three bugs seems interesting but have some disadvantages, making it a little bit complex to exploit since we need to control the system property. So does there exist any easier way to exploit? And at that time, we didn't have any good ideas, and just based on the experience of previous vulnerability, and we may know that not only does the JDBC driver need to support the login function of the login context to trigger the JAAS process, but it also needs to support setting the system property or security property to let us control the evil JAAS config. So we just download the Java libraries as many as possible and do some static program exercise to find the possible bug and manually review the code and check if it meets our requirements. So we totally found 12 vulnerabilities, and this involves Databricks, ISO, AWS, CloudRoll, Inside Software, and IBM, and also 2 vulnerabilities from a Chinese company. And AWS acknowledged the vulnerability, but I'm willing to assign CVE number, so I don't know why. And the CloudRoll also shared the 2 vulnerabilities with the same CVE number. And the Databricks rewards us with 3,000 bug bounty, and the CVE number is the 2 vulnerabilities from Chinese company. And another interesting thing is that the Inside Software company provides a lot of JDBC driver solution, and you can see that totally 55 different JDBC driver. And so we download JDBC driver of the company provided and analyze them. And some of them are commercial products, so we cannot download. And although the CVE number only contains about 2 vulnerabilities, but in fact, totally 5 different JDBC drivers have this kind of problem. And the latest version of the JDBC driver all fix this issue. And let's use the IBM vulnerability to share. And you can see that here in the code, and it indeed supports that some property of the Java security auth login config, and it just gets the configuration from the connection tree. So here we don't need to manually set the system property, and we can just control through the JDBC connection tree. And so it is easier to exploit. But the question is how to trigger the bug. And so also we need to find the place where call the login method of the login context. And this is the Kerber logon function. And here you can see that the connect function just calls the Kerber logon function. And you can see that it has the check. So we need to set authentication mechanism to Kerberos, and there is similar reason. So why our Microsoft SQL Server need to set the parameter. And also there is one thing need to emphasize. It has another check. So we need to set the username and password. And here this is the poke, and you can see that here we don't need to set the system property, and we can just configure the JS config through the JDBC URL and the JS login config field parameter. And also we need to modify the JS config name. And here this is the exploit video, and you can see that. So this is the poke, and this is the JS config. And we need to start a HTTP server, and we start the UGNDI server. And if we run the code, and also RCE again. So this is the exploit flow, and you can see that So first, we set up the evil HTTP server and the evil JNDI server, and we set the JDBC URL. And the JDBC driver will pass the URL and will set the system property, and it will then use JAAS to log in. And the JAAS will try to get the configuration from the remote HTTP server. And it will do authenticate and will send a lookup request and will achieve RCE. So these vulnerabilities are all due to the insecure integration of JAAS. And perhaps there are still some omission and waiting for you to discover. And next, I will introduce the impact of the JDBC vulnerability. So which applications are exposed to the JDBC vulnerability? And after my exploration, there is some common scenario. So first is data processing or data integration, and this product just assists users in managing data or conduct data analysis. And next is the data visualization, and it just helps users to better visualize and experience data more intuitively. And here the affected servers include the community or commercial products or cloud vendors. And so here there are many these kind of products like Cloud Beaver, Tenant, or Power BI. And this is what the feature looks like. And you can see that the web server just allows user to input the JDBC URL, and the server will connect to it and will do some data processing. And so when we input our evil JDBC URL and a test connection, and the server will first send the JAAS configuration request, and it will then send a JNDI request. And if the server runs on an old version of JDK less than 8U191, and we can easily achieve RCE by remote class loading. And if not, we need to try to find a deserialization guided chain. But by default, many companies still use old version of JDK due to the compatibility issue. And even if they are running on the new version of JDK, and it seems not a hard thing to find the deserialization chain. And some common libraries like FastJackson, Spring Boot, both have some interesting chain. And this is the awesome GitHub project collecting common deserialization chain. And you can gain inspiration from it. And the next part is the cloud vendor. So here, this is what the feature look like, and you can see that it just allows user to input the username, password, database host, and port. And there are two common vulnerable implementations. So above one, and you may be familiar with, and you can see that it just let the user control the whole JDBC URL. And the below one, you can see that it just let the user control several fields. But the problem here is it don't perform any validation. It just concatenate the field together. So we can just input some additional parameter and achieve the same effect as controlling the whole JDBC URL. And here, this is the possible server-side implementation. And you can see that the user will first send the database configuration to the config server, and the config server will schedule the request and let the executor to connect to the user data source. And so if the attacker just sends some evil payload, and the config server will send it to the executor, and the executor will connect to our evil data source, and we will achieve RCE. And so when we control the executor, and since the different users share the same executor, and we can easily achieve cross-tenant access attack. And besides the scenario, and what else? So if you are familiar with database, and you may know that the database usually support external data source. And here, like a Microsoft SQL Server, and you can see that it supports different kind of data source like Azure storage account, Azure data lake, and remote SQL Server. So if a database supports a vulnerable JDBC driver, and we can achieve RCE, and we can control database server. And by default, XO supports this kind of feature. And also Databricks supports this kind of feature. So here we just take the XO as an example to share, and you can see that first we just connect to the database server, and we execute a query to create a connection, and then we just use this connection, and the database server will try to connect to our evil server, and we can achieve RCE. And we can also use this vulnerability to implement a honeypot system. So one day when you try to hack a company, and you use a mining tool to gather information of the company, and you finally find this secret page, and you can't wait to connect to the database and earn the bug bounty. And when you look at the connection string, and if you don't know the vulnerability, and you may consider it is very safe and normal connection string. And even if you notice the curb JAAS field parameter, and you may just consider it as the needed and important parameter, since it may hold the credential. And you are very excited, and you use some tool like dbeaver to connect to the database, and you can see that dbeaver just use the JDBC driver to implement its feature and use it to connect to the database. So once you connect it, and sorry, but you are just hacked. And finally is the defense recommendation and a summary. So for the application like cloud service or community product, and we should not trust input from user. And we should actually update Java libraries. And also for Java libraries like JDBC driver or Kafka client, we should better disallow the dangerous login module or only permit trust one. And for JAAS or JDK, and I think it is better to disallow loading JS configuration remote. And we should also better to disable dangerous login module by default. And this is some takeaways, and you can after this sharing, and you may know how to use JAAS and how it works, and you can know some vulnerabilities about JAAS and their root cause, and you can also acquire a new JDBC attack, and you can also know the impact of the JDBC vulnerabilities. And the story may come to an end here, but the story of JAAS may not end here. I have also found another bug of a famous company, and they just rewarded me with the highest ever bug bounty in their history, but since they have not published the security alert, so I can't share here, maybe next time. And so do you have any questions?
Due to the time schedule we have, we can open one question to the floor. If not, I have received one question. Did you use tools like CodeQL to find the val, or just found it by code auditing?
Don't use CodeQL, and just our self-implement
Custom tooling.
Yeah, and very simple. We just need to find the sink, and we don't analyze the core root. We don't need to know the source or sink. We only need to know this library just call this function, and then we manually review it. And so very simple tool.
Thank you. All right, thank you so much for the great session.